Okay, welcome everybody. We are in our first module of structural analysis 2 and this is our fourth class for module 1. So we are studying how to analyze a continuous beam using Clapeyron's theorem of three moments. Now, in today's class, we are going to see the procedure for analyzing a continuous beam using Clapeyron's theorem of three moments. Now, okay, so step 1 is draw the simple beam moment diagram for each span of the beam. So we know this Clapeyron's theorem of three moments is specifically for analyzing a continuous beam. So suppose we have a continuous beam like this, and if the length of the span, we will take this beam as A, B, C and D. So length of the span AB is taken as L1, length of the span BC may be taken as L2, length of the span CD may be taken as L3. Now, there may be uniformly distributed load, there may be a concentrated load at the center of the span or concentrated load not at the center of the span or triangular load or any type of loads. So here for the span AB, this load we will take it as W1. This for BC it may be taken as W per unit length, and CD this load can be taken as W2. If this is the loading condition, also this distance W1 is at the center of the span, so this is L1 by 2 and this distance is L1 by 2. Here the distance is different, so we can take it as for span CD, we can take the distance where the load is acting as A and B. Okay, now our first step is, if such a diagram is given, our first step is to draw a simple beam moment diagram or simple bending moment diagram. See, simple bending moment diagram means we have to draw a moment diagram by assuming the end supports are simply supported. So now, how will we draw the simple beam moment diagram for this beam, for this continuous beam? So we will draw like this, we will draw the span. See, for AB, it is a concentrated load in the span AB. So if it is a concentrated load, for the span AB, our bending moment diagram will be like this. It will be linearly varying. So it is a center. So we know the center, if a concentrated load is acting at the center of a simply supported beam, the center bending moment will have the maximum value, and that will be equal to WL by 4. So here it is W1 L1 by 4. Okay, because it is a simply supported beam, a concentrated load is acting at the center, that is why it is WL by 4. Now, for the span BC, it is a uniformly distributed load, so that our bending moment diagram, simple bending moment diagram will be like this, and we know the maximum value of bending moment is equal to WL square by 8. And for the third span, the concentrated load is not acting at the center, therefore we will get the maximum value for bending moment at the point where the concentrated load is acting. So here we will have the maximum bending moment, and our bending moment diagram will be like this, linear straight lines, and the value for the maximum bending moment at this span will be equal to WAB by L. So here W is W2, load is W2 multiplied by A into B divided by L is L3. So this is your simple beam moment diagram. So this is your first step. So any any continuous beam is given for you. First of all, you draw the simple beam moment diagram. Okay, and remember, when there is a concentrated load at the center of the span, the maximum value, bending moment value will be at the center, and that is equal to WL by 4. For a uniformly distributed load, the value is WL square by 8, and for a concentrated load at some place away from the center, it is WAB by L, not WAB by L, it is WAB by L. So we have to remember these things. This is our first step. Now we will go for the second step. Now the second step is compute the area and locate the centroid measured towards the end of each span of simple beam moment diagram. So this is our beam moment diagram. We have already drawn in our first step. So now in the second step, we have to compute the area of this beam moment diagram. We need to find two things. We need to compute two things. First is the area. First thing we need to compute is the area, and the second thing is we need to locate the centroid. Okay. So two things we have to do in this step. So first of all, we will locate the area. So locating the area is, see, first in the first simple beam diagram, we will calculate the area as A1. The second beam moment diagram, we will calculate the area as A2. And the third diagram, we will calculate the area as A3. So calculate all the area, A1, A2, A3. Also, now we will locate the centroid measured towards the end of each span. See, now you should be careful, because we know this Clapeyron's theorem of three moments will be applied for adjacent beams. Adjacent beam means, see, first set of equation is derived for the beam AB, BC. So first case you will take AB, BC. You will apply the theorem of three moments. Now second case you will take BC and CD. So these two beams spans will be taken together. These two spans will be taken together. So when you take the first span, you will get a set of equations. You will get one equation. When you take the second set, you will get another equation. So now I will explain you later. Now see, when you take the span AB and BC, when you are considering AB and AC, you have to calculate. See, now our area is A1, A2 and A3. Similarly, the centroid will be X1, X2 and X3, because we have three spans. Now, when you are considering AB, BC, our X1 should be calculated. You take the centroid. If this is the centroid, our X1 will be calculated from the left end of the span. For BC, if this is our centroid should be calculated from the right end of the span. Okay. That is why it is said as towards the end of each span. Towards the end of each span. Now, when you are taking the span BC and CD, when we are taking the span BC and CD, that is the second the second condition. Okay, so when you are taking the span BC and CD, our x2 will be calculated from this end. So this will become our x2 and our x3 will come from here. This is x3. So you should be very careful while taking your centroids. So centroids for each span is calculated from the extreme ends, is to be located from the extreme ends. So this is our second step. Now we will move on to our third step. So first step, we are drawing the simple beam moment diagram. Second step, we are calculating the area and we are locating the centroid towards the end of the span. Now we will move on for the third step. So step 3 is identify the support moments which are to be determined. So how will you identify the support moments? Now see, if our beam is like this, okay, we have a set of continuous beam like this, we will have the support moments. See, at all the intermediate supports we will have moments. We will take this as A, B, C, D and E. Remember, all the intermediate supports we will have some moments. So this moment, the magnitude of the moment will be MB, MC, MD. So all the intermediate supports we will have moments. End supports, if the end is a fixed support, you will have a moment. So here E is fixed support, we will have ME. We will have a moment ME. But A, the end support A is simply supported. So here the moment will be equal to 0. This is how you have to identify the support moments. I repeat, all the intermediate supports will have moments, will have support moments. So B, C and D are intermediate supports. We will have support moments MB, MC and MD. The support A is simple support. So this is an extreme support. So end support. It is simply supported. So moment will be equal to 0. The end support E is fixed support. So moment is not equal to 0. You will have a moment ME. You will have a magnitude for the moment. So now our aim is to find what is MB, MC, MD and ME. Okay. So we have identified the support moments. So next step, apply 3-moment equation for each pair of span. That means, see, suppose we have the span like this. So we will take the same span A, B, C, D and E. Okay. Now, I told you we will be applying the 3-moment equation by taking this pair of spans. So this is our first span, second span, third span and fourth span. Okay. Now our unknowns are, here the moment is at A, moment is equal to 0. Here MA is equal to 0. But we will have MB, MC, MD and ME. That means we have 4 unknowns, 4 unknown moments, 4 unknown support moments. So we need 4 equations. So we need 4 3-moment equations. So first moment of equation will be obtained by taking the span AB and BC. So apply 3-moment equation. Apply 3-moment equation. We will get an equation in terms of MA, MB, L1, L2, I1, I2, etc. Now, for the second equation, we will be considering the span BC and CD. Now apply the 3-moment equation. For the third equation, we will take the spans CD and DE. Now apply 3 moment equation, you will get an equation. Now see, our unknowns are MB, MC, MD and ME. 4 unknowns. We have only 3 sets of equations. Now for the fourth equation, you have to see, since E is a fixed support, we will assume a dummy span to the right of E. Now if A is fixed support, we will assume a dummy span to the right of it. Now if A and E both are fixed supports, we will assume a dummy span to the right of A as well as a dummy span to the left of A as well as a dummy span to the right of E. Then only you will be able to get 5 equations. Okay, here only E is fixed, so that we will take a dummy span to the right of E, and this support will be considered as symbol support. We will take it as F. This is a dummy support. So fourth equation, we will be taking the span DE and EF. Then we will apply the 3 moment equation. Now we have 4 equations. 4 equations, 4 unknowns. So solving these 4 equations, we get MB, MC, MD and ME. Now our fifth step is the solution of these equations gives the values of the support moments. So solving all the 4 equations, so depends upon the number of span. Okay, these equations depends upon the number of spans, the number of support moments to be determined. If you need to determine 4 support moments, you should have 4 equations. That means there should be 5 spans. If there is less than 5 spans, you will add a dummy span. Okay, that means, see, if you have here it is 1, 2, 3, 4, 5 spans, and the unknowns are 1, 2, 3, 4, 5 unknowns. So number of equations will be, this is 1, 2, 3, 4, 5 unknowns, only 4 equations. So you will add a dummy span, you will get 5 equations. So if there are n span, you will be getting n minus 1 equations. Okay, and depending upon the unknowns, we will add a dummy span either to the right or to the left of the support. So solving these equations, you will get the solution, you will get the value for moments. And our last step is after obtaining the moments. See, now after obtaining the moments, if your beam is like this, with a concentrated load, with a uniformly distributed load and with another concentrated load, your bending moment will be like this. I have told you the values. Your bending moment will be like this, and here it is 0. You will have MB, then you will have MC, you will have MD. So this will be your final bending moment diagram. So this will be negative bending moment at the supports. Near the supports you will have negative bending moments, and away from the support, the remaining region, you will have positive bending moment. Okay, so this things will be neutralized. Okay, this portion will be neutralized by positive and negative bending moments. There will be no hogging or no sagging. So your deflection diagram will be like this. It will come here like this. Okay, now you will have So this will be your deflection diagram. Now you can obtain the shear force diagram. Listen, now you have all the moments. Now by equating the moments, taking the sections at the supports, and by equating the moments, you will get the reactions. You will be able to find all the reactions RA, RB, RC and RD. Now after finding the reactions, you will be able to draw the shear force diagram. So with that your analysis will be over. So analysis means you have to, if analysis of beams means you have to know how to draw the shear force diagram, how to draw the bending moment diagram, how to draw the deflection diagram, and what about the magnitudes, where the bending moment occurs, where the hogging moment occurs, where the sagging moment occurs, how was the deflection, where the slope is equal to 0 or not, etc. Okay, so concluding, so these are the 6 steps required for us for analyzing a continuous beams using theorem of 3 moments. Now, concluding, so step 1 is draw the simple beam moment diagram for each span of the beam. Step 2, compute the area and locate the centroids measured towards the end of each span of simple beam moment diagram. Step 3, identify the support moments which are to be determined. Step 4, apply 3 moments equation for each pair of span. Step 5, the solution of the equations gives you the value for the support moments. And step 6, the reactions at the supports and the shear force diagram can be obtained by using the equilibrium equations. Now, we will go on for solving our problem.